Hey, welcome back. I'm still Nick from Hazmat Biohazards, and this is episode 4 of the FTC Student's Guide to Autodesk Inventor, where we're going to learn all about life, the universe, and sketches. So, last time we looked at assemblies and constraints, which are how you put different parts together, but today we're going to get into making our own parts by starting out with sketches. So a sketch is a 2D drawing, meaning it's on a plane called a sketch plane. A sketch itself has no volume because it's only in 2 dimensions, so you can't really constrain anything to a sketch, and it's not going to behave like the solid parts we've been working with so far. Sketches are pretty useful, however, as they are the first step to creating custom parts or editing existing parts. So let's get started here. I was just on the home menu where I clicked create new part, which brings us here to our workspace. And looking at the tools it pulls up for us, you can see pretty easily how important sketches are to the CAD process, because right here under 3D model, not even in the sketch tab, it has the create new sketch tool. So whenever you want to make a new sketch, go ahead and hit that button. So then Inventor will basically ask you what plane do you want this sketch to be on, which is a pretty important question that will determine the orientation of your sketch. So let's put sketches aside for a second and just talk about planes. So in order to position our sketch how we want to, we first have to find a plane that we want the sketch to be on. So since we're starting from scratch for this part here, it's not really that important what orientation the part is in. So just going ahead and clicking on one of the ones that are given, these are the origin planes, what it's called, is fine for this purpose. But let's say you want to put a sketch on the side of a part or an assembly, which is a pretty common situation for FTC when you want to build a part based on another part. So we can actually select any planar face on any existing part on a part or assembly, and then we can get our sketch plane to be on that. You don't really have to worry about the shape or the size of the plane, as remember, by definition it's infinite in all directions. So you really can just build on a plane. It doesn't matter what it looks like, or if it looks super small, you can just go way off of it. It doesn't matter really at all. So this bit is kind of complicated, and honestly, I've barely touched these tools when working with Inventor. But there are some tools I thought I would point out, which are all about placing planes. So if you're in an assembly and you want to make a part in a specific orientation, you can use these tools to help define your own plane. Check these out when you get stuck. Once you've selected a plane for your sketch, you'll see the camera turn to give you a top-down view of your plane. Now we're ready to start sketching. The line tool is a really basic sketch tool used to obviously make lines. Click to place the starting point of the line and then move your mouse and click to where you want to make the second. This is fine for sketching general shapes, but if you want to make a line more precise, you can define a length and an angle in the text box that pops up. Press tab to change between them and type the length you want. It's cool to note that you can use whatever units you want by specifying inches, feet, centimeters, or for angles, you can choose from radians and degrees. Quick little side note about units, it doesn't really matter what you use. I would just recommend that you're really consistent with what you're using. So when you CAD your robot, either to do it in inches or in millimeters or centimeters, just make sure you stay consistent so you don't have trouble with part scaling when you go to 3D print or CNC machine some of your parts, because that can be pretty annoying to deal with. So coming back to sketches, you can see that if you click on the line, you can drag it around and move it. And if you click and drag from the endpoint, you can actually change the angle or orientation or the length of your line. This is because this line is undefined. So I did not set a length or an angle in the boxes just a second ago. So it's variable with me dragging it around. And this makes it really easy to work with them when trying to figure out a sort of a rough shape, but it also means you aren't precisely defining anything. And also, if you move like a line accidentally, so you accidentally click and drag on this part, you can totally mess up your sketch because it's all unconstrained. It's sort of the same idea with fully constraining parts in an assembly that we talked about last episode, how a part can be fully constrained. Well, if you have a line that's not fully constrained, you sort of run into some of the same problems. So in order to define our lines, let's take a look at the parts of a line that we can actually select. So let's try out the point tool and look at this line. If you hover over the endpoints, you see this green dot. And this is sort of like a little magnet guide that will put your new point exactly on the endpoint. And if you come to the middle, you can see here we have the midpoint. And these points are selectable from almost anywhere. So let's try a few other tools. Also, just as a note, if you click on a tool and you have this little prompt on your cursor and you want to get rid of it, just press escape and it will close. So let's make another line here. I'm going to click on the midpoint as the first point in my new line and then click out here somewhere. So now I can do the same thing again with these 2 new endpoints to make a little triangle. So let's look at all the other tools now. You have a circle, which you can just click a center point and then define a radius. The arc tool comes in a few varieties that are all useful. So there's a center point one where you can make an arc that's sort of part of a circle like we saw. Tangent arc will make an arc off a line that's tangent to that line. And then 3-point, which is a cool one where you can make a line and then sort of define the radius and the curve of that line, which is probably the most flexible. So now we have a fairly interesting sketch here, but none of it is really precise. I mean, you remember what I said earlier, that you can define the lengths of lines using the dimension boxes that pop up, and I'm sure you just saw that with other tools like arc and circle, you can put some measurements there too. And since our sketch is undefined, or more accurately, it's unconstrained, you can see that you can still move it around. So in the last video, we talked about constraints and assemblies in 3D space. So we wanted to put two parts together. We wanted to align certain axes of holes or axles, and we could set them to certain angles and all sorts of things. With sketches, it's the same logic, but the tools are a little bit more intuitive. And actually, we've already started working with them and you didn't even really know it. So in this sort of grid-like bar up here, you can see we have a bunch of different constraints just for sketches. So sketch constraints, right? So let's start with the one called the coincident constraint. So when two things are coincident, it means they're in the same place. You can think of it like they're overlapping if you want. So when we had a line and we put another line and started it from the midpoint of the first line, you can see that no matter how we move either of these lines, the endpoint of the first line is always at the same place at the midpoint of line 2. They are coincidentally constrained, which is indicated by this little yellow square on the point. And really all that means is just that it's locked in place, that the endpoints. So you can think of like the holes that we had earlier on the assembly, right? So setting 2 points as coincident is really easy. So if you make 2 points, 1, 2, and you click this little coincident constraint box and select one of them and then the other, you see that they snap to the same place. So we can do the same thing with lines because lines have points on them. If we have two lines and we want the endpoints to meet or coincide, we can click the constraint and click the two endpoints and boom, now you've got a little angle. Speaking of angles and constraining sketches, let's put all the constraints aside for a second and talk about the dimension tool. I don't really know if this is technically considered a constraint, but it functions like one in a lot of ways. So if you click this little magic tool and click on a line, you can define how long it is. Remember we just had the chance to do this earlier when the dimension boxes pop up and we're making the line. If you made a line first and you wanted to figure out the rough shape, you can always go back and redefine dimensions using this tool. So we can define the length of the line by clicking on it and then clicking to place this little dimension indicator. If you want to change it and you already have a dimension like this, you can just double click on this indicator again later and it will bring up a text box and you can easily be changed. So anything with a dimension little text box thing that pops up when you make it, so think about like the radius or diameter of circles, you have arc radiuses, you've got angles of lines, all that stuff can be defined through this dimension tool. Also, hot tip, pressing the D key is going to open up this tool, is really useful. So this tool actually becomes even more powerful depending on what you actually select. So take our little angle that we made earlier. If we click on one line segment and then the other, we can actually just set the angle between them. That's pretty cool. If you have two parallel lines, which is actually just another constraint, this parallel constraint, we can set a distance between them. So this tool is the real key to making your sketches precise for sure. Another great tool is the measuring tool, which can be used to get the measurements of any dimension that you have on your sketch. So click a line, a circle, whatever, it'll tell you its dimension. Like dimension, you can click on two lines to get an angle or distance or whatever you want to find. All right, so you won't use all of these constraints. Some of them I'm not even really sure how to use, but let's rapid fire a few really useful ones. So we just saw the parallel constraints with lines, and right next to it is the perpendicular, which forces two lines to be perpendicular. 90-degree angle. Tangent can be used with a circle and a line to make a tangential relationship. These two with the jagged edges are the horizontal and vertical constraints, which sort of help you anchor your sketch to the CAD space, like those planes we saw earlier. I don't know how many of you have ever played Minecraft, right? Like you think about like your whole world, you've got like 3 dimensions, like your X, Y, and Z dimension, right? And there's like fine lines of where those are. So you can almost think that like CAD space has like coordinates like that, And you don't always deal with them directly, but you can align things to certain axes and those planes. You can sort of think of it like an origin plane, that sort of deal. That stuff is all pretty important for CAD. Concentric circle constraint makes two circles have the same center point. The equals constraint is a pretty cool one. So this forces two lines, circles, arcs have the same magnitude. So whether that's a length, diameter, radius, or whatever. So if you have two lines, we can constrain them to have equal lengths with this tool. Those are the sketch constraint tools, and using those, you can make lines or shapes however you want. Now, a few other things with sketches. So in here, we have a bunch of movement tools, and some of them are really similar to what we've done by clicking and dragging. So I'm not going to go too in-depth on them. They're pretty intuitive to use. Don't forget, you can copy and paste lines, circles, or larger sketches just like you can parts. That can really save you some good time. Another time save is the rectangle tool, which is a simple one that just makes a box. Now, using all of our constraint tools, we could very easily make this shape ourselves, but this is considerably faster. There's a fillet and chamfer tool, which we'll talk about more during our 3D modeling. These are good for rounding out our sketch drawings, cleaning up sharp corners or whatever. If you select two lines forming an angle, you can fillet it, which is like this rounded circle edge by setting a radius, or you can chamfer it, which is sort of this triangular cut by setting a distance. Now in this pattern box, there's some more advanced stuff, which I don't really use that much. Mirror can be pretty useful though, so let's look at that pretty quickly. If we make some sort of shape and then select a line to mirror it over, we can quickly flip it to the other side of that line. So this is really useful if you want to make symmetrical drivetrain panels or anything that's mirrored. So that's just about all you need to know about sketches. We're going to revisit some of this stuff in the next couple episodes when we're making our own parts, but now you should be able to design basically any 2D shape you want. You can add arcs, you can add boxes, figure out how to make some hexagons, really any shape you want using the tools that we've just gone over. So play around with them a little bit if you want, experiment with the different tools so you know how they work, and then I'll see you in the next episode where we start making our own parts from these sketches. That's going to be fun. Anyway, see ya.